All right, kids, welcome back. It's Tuesday, April 14th, second day back after spring break. Hopefully, your first day back went okay. You got your work completed. For me, you watched your video, you filled out your quiz, got that sent to me. If you didn't, I'll be sending you an email reminder to let you know to still do that. Uh, Yesterday, our big topic was clouds and how clouds form, and then specifically the four types of clouds that I'm interested in you knowing: cumulus, stratus, cirrus, and then nimbus clouds, which are responsible for precipitation. All right. There's a little bit more with clouds that I didn't get into that go along with their the naming of them and their prefixes. Basically, the prefixes are based on their height, like how high up in the atmosphere they are. And you can see those prefixes here: cirro, alto, strato. So you might have a cirrostratus cloud or an altostratus cloud or a stratostratus cloud, which is kind of weird. All right. Um, I'm not too terribly interested in those for you. We have to pare down the information that you really need, and I'm not so sure that you need all of that. All right. Today's topic is going to be about precipitation and how precipitation forms and how each of the four types of precipitation forms. And then we'll move a little bit on to air masses. All right. So as you look over my right shoulder today, we have the four kinds of precipitation: rain, snow, sleet, and hail. Now, you should be familiar with all of these, although sleet can be a little bit of a weird one. Like, maybe you know what that is, maybe you don't. I always find one thing weird: hail, ice chunks. They can be smallish, quarter size, pea size, dime size, or they can be softball size or even bigger. I think the biggest one is somewhere in the neighborhood of over 1.5 pounds. Imagine getting hit by a 1.5 pound chunk of ice falling from the sky. But here's the weird part: when do these chunks of ice fall from the sky? Is it when it's cold out, let's say winter, or is it when it's warm out, like summer? When do the chunks of ice fall from the sky? That's correct. I have never seen a chunk of hail fall from the sky in the winter, and it never will. And we're going to get to why that happens in a little bit. But hail, those large chunks of ice, always, always, always fall in the spring or summer, fall, when it's warm out. All right. Now, back to precipitation. Remember, those clouds are made of tiny water droplets, liquid. All right. When those droplets, very tiny, smaller than an eyedropper full, when those droplets are moving around up there in the air, they collide. And as they collide, they get bigger. And once they're big enough that they can fall through the wind that is up there through that air movement, then it falls down to the surface as precipitation in one of those four ways. All right. Now, which way the precipitation ends up down here at the surface, which type, rain, snow, sleet, or hail, depends on the temperature of the air at different layers: the temperature of the air up by the clouds and the temperature of the air down here at the surface. So let's run through that very quickly. So imagine the temperature is warm up by the clouds and it's warm down here at the surface. Which of these types of precipitation will fall? Well, if it's above 32 degrees up at where the cloud is, it's above 32 degrees down here, it's going to stay as a liquid and it's going to fall as rain. All right, so warm air up by the clouds, warm air at the surface, we get rain. Snow, the opposite is true. If it is cold air below 32 degrees up by the clouds, and it's cold air down at the surface, it falls down as snow. It stays frozen. Sleet is the weird one. Sleet is those tiny little like pellets, those little pebbles of ice that fall occasionally. And when sleet forms, what happens is we have warmer air up by the cloud above 32 degrees. It's still a liquid, right? It falls down as a raindrop, but that raindrop passes through cold air on its way down to the surface where it freezes as a little tiny ice pellet. And then we get sleet. Weird, right? A frozen raindrop is what sleet is. All right. So we've got the rain. It's warm up there. It's warm down here. We have snow. It's cold up in the clouds. It's cold down here. And we have sleet where it's warm up, where it falls as a raindrop and it passes through cold air and freezes. That's sleet. The fourth one that we have is hail. And hail is interesting and different. And there's a little picture right here that I will try to zoom in on. No, I can't zoom in on it. Hail happens in the summertime when we have those very tall cumulonimbus clouds, those thunderstorm clouds. And they're in the warm part of the troposphere at the bottom of them, right? Because we're going to get rain. But they're so tall, and it happens on hot summer days when the hot air is rising and rising and rising up towards the stratosphere. And in fact, cumulonimbus clouds can reach into the stratosphere. But at the top level, it's cold, it's freezing, right? We saw that on our temperature graph. When we get to the top of the troposphere, it's very cold, it's below zero. So what happens in these thunderstorm clouds is we get a chunk of ice that falls from the top of the stratosphere, and it falls down through the cloud where it starts to melt. And in thunderstorms, on those hot summer days, there's so much hot air rising that the hot air actually pushes that chunk of ice back up towards the top of the cloud where it's cold and it refreezes. Eventually, it starts to fall back down and melt a little and melt a little. And if it gets pushed back up, it refreezes. And if that happens over and over and over again, that chunk of ice, which starts very small, can get bigger and bigger and bigger. And once that chunk of ice is big enough that it can withstand the air pushing up, that hot air rising, if it can fall through there, it gets to the surface as a chunk of hail. All right, so hail, fortunately, is pretty rare, but it can cause damage. It can actually even kill people if it's big enough and it hits them in the right or wrong spot. So hail, those big chunks of ice, happen in a cumulonimbus cloud in the summertime when we've got nice hot temperatures here. All right, so those are the four types: rain, snow, sleet, and hail. We're going to get to more about each of those when we talk about severe weather, probably starting tomorrow. All right, now those are the types of precipitation. What I want to focus on for just the last couple of minutes here are air masses. And when you look at this map of air masses, what you should see are the characteristics of the air masses are the same as the characteristics of the land or water below them, right? So when we look here in Mexico, Texas, hot and dry there, the air above them is typically hot and dry. Canada, cold, dry air, we think of it as snowy. The air above it, also cold and dry. When we're coming off of the coast up here in the north, we get cool, moist air and cool, moist air. And when we come off of the coast in the south by California or the Baja of Mexico or Florida, we get warm, moist air. Now, how do these air masses relate to anything else? Well, the deal is that where these air masses meet is where we get interesting weather. That's where we get the cloud formation. That's where we get precipitation. All right. So if this hot, dry air matches up or runs into this cold, dry air, the hot, dry air rises, right? Where it cools off and it condenses. Now it's dry, but it still has some water vapor in it. So that's still going to form clouds and potentially precipitation. All right. So wherever these air masses meet, that's where weather is going to take place. Now we have some names for them. Before we get to those names, the cold fronts and the warm fronts, just briefly uh, talk about highs and lows, high pressure and low pressure. High pressure, if you remember, is because we have air that's sinking. It's pushing down on the scale down here at the surface. It's pushing down, it's making that number go higher. So when we have sinking air, it's cold, and it also creates high pressure. When we have rising air moving away from the scale, rising air is warm, so that warm rising air creates lower pressure. So those are highs and lows. We also learned that wind always goes from areas of high pressure to areas of low pressure. Here's how I think about highs and lows, high pressure and low pressure areas. High pressure, nice weather. Low pressure, crappy weather. Again, for me, nice weather means sunny, warmish, right? Not raining. That's high pressure. Cloudy, gloomy, rainy, that's low pressure. All right. Rising air means low pressure, but it also means that it cools, it condenses, it makes clouds, and it makes rain. All right. So those are the types of pressures that we have: high pressure areas and low pressure areas. Last thing that we'll talk about very briefly are fronts. Cold fronts and warm fronts are the two that I need you to know. And the pictures of them are right here. Fronts are basically those air masses as they're moving into another area. All right, so a cold front is right over here, and it is simply cold air that is moving into an area of warmer air. And when that cold air moves in, it pushes up the warm air where it condenses, and you can see forms very tall clouds, which we would associate with a thunderstorm or heavy rain. All right. So when a cold front moves in, our temperature down here at the surface cools off, and typically right on the edge of that front, we're going to get some pretty heavy rain. All right. So that's a cold front. A warm front is when warm air moves into a location that has cold air in it. And as that warm air moves in, keep in mind it's still less dense. And so it rides over the top of the cold air. And when it rides over the top of the cold air, it moves up in the atmosphere, it cools off, it condenses, forms clouds, and eventually forms precipitation. So, cold front, cold air comes in, pushes the warm air up, makes rain. Warm front goes over the top of the cold air, still rises, still condenses, still forms clouds, and still forms rain. We can get an idea of the types of clouds in these different fronts. In a cold front, you can see we've got these tall cumulonimbus clouds, typically associated with a thunderstorm or heavy rain. And in a warm front, we have these cirrus clouds way out at the front. So first, we're going to see these cirrus clouds. It's not going to rain. They're frozen ice chunks way up in the sky. Then we have some thicker cumulus clouds, and eventually into some stratus clouds, which are going to create a much more prolonged rain, usually a day or a couple of days, that we're going to have rain for a warm front. So, went over a lot today. There are a couple of other kinds. An occluded front, which basically means that warm air is cut off from everything. Not terribly important for us today. And then a stationary front, and that is, it's just kind of stuck stationary. And so when we get stuck in a stationary front, we end up with rain and rain and rain and rain and rain. Or it could possibly be snow for a long time because that air really isn't moving. They're kind of stuck together. All right, not moving at all. So today went over a lot of stuff. We went over the 4 types of precipitation: rain, snow, sleet, hail. Hopefully you remember them for the quiz. We talked about the different air masses and how they're associated with the temperatures and moisture at the surface is the same as the air above it. Highs and lows. High pressure means good weather. Low pressure means crappy weather. And then we have the different fronts, the cold front and the warm front, which are right here. So that's it. That's like a 15-minute video. I hope you watched it to the end. Don't let me see those short run times on my YouTube diagnostics. All right, watching all the way to the end. That's your job. Take the quiz, and when we come back tomorrow, we are going to start severe weather. Some fun stuff, death, destruction, all that good stuff. So until then, I hope you have a great day, and I will talk to you tomorrow.